Good evening. Now, this problem, I think all of you have read it now. See, now let us try to understand the solution to this. We have solved similar problems. That is, we used to have it like this. Okay, there is a spring. You remember? There is a spring. Okay, and to this you have a mass m. Okay, and say that this is at position x is equal to 0, and the spring is in its relaxed position. I am holding it. I am holding the mass in my hand. Now, the moment I release the mass gets released. It will come to this position. Say this is x is equal to x1, and at this position the velocity v is greater than 0. At this position velocity v is equal to 0, and then the mass will further descend down to this position. Okay, and this position will be x is equal to 2x, and the velocity here is 0. I hope you comprehended this situation.
Yes, sir.
Great. Okay, fine. Now let's understand this. What takes it from this position to this position? What is the reason the mass will travel from this position to this position? Because at this position the net force F net is equal to 0. I hope you all know that now at this position.
Yes.
Yeah. Now what takes it to this position?
It has got some velocity.
It has got some velocity, it will take it to this position. Correct? That's the deal.
Yes.
Okay. So now if I now ask a question, what is the maximum displacement? The maximum displacement. Okay. The displacement that is maximum here will simply be equal to 2x. I suppose it is understood.
Yes, sir.
Correct. Okay. Now, supposing I have this initial position, and then I will slowly bring it down. I will slowly bring it down to this position, to this new position. X is equal to say some x naught by 2. I bring it to this position. Okay, I bring it in my hand, and then I release it. Okay, now this will once again come to this position, so this condition will be satisfied. Correct? Hello? And even at this position, velocity v is equal to 0 because I am holding my hand. Correct? Hello?
Yes, yes.
Now it will continue to come to this position, and then will it come to this position?
No, sir.
Yes, it will stop at this position. Correct? So now you see what is the so supposing you have taken this position to be the initial position, then the transition here is only going to be what? What will be the maximum displacement in this case? What will be the maximum displacement in this case? Okay, it is definitely going to be 2x1 minus, since it is x naught by 2, this will also become what? X naught by 2.
Yes, sir.
Okay, so therefore this will simply reduce to 2x1 minus x naught. Clear?
Yes.
Right. So in this situation here, what we have is, assume that I have not left it at, it is in its, assume that this is in its x is equal to 0 position, and this is in a relaxed condition or relaxed natural condition. Now supposing I had left it down, I had left my hand down, okay, then I would have got this equation, mg into x is equal to, hello, what is this going to be? R k into 2x square. Correct? So yesterday we solved this and we got the x here as you can tell me here what will be x, mg by 2k. Correct? Now the problem given is that they have, when the spring is when the extension of the spring is x naught. That means this would have come down to the position x naught by 2. The same situation as it is. Okay, so therefore this would have been the maximum displacement had I released it from this. Now, since that it is released by x naught, this would have come down to a position x naught by 2. Okay, so the same logic holds good, and therefore the max will be this minus x naught. Clear?
Yes, sir.
Satisfied? That's it. That's the logic was this. Anyways, we missed it out. But you see, now please ask yourself. Yesterday we got into this situation. Okay, and then we struggled for about 5-10 minutes. We said, fine, let's think it over. We all thought. Now you see, whatever effort that I and you have put will definitely be in the form of knowledge, skills, etc. Okay, if you simply see some book and get the answer, okay, then, well, we are all wasting time. Okay, I suppose we all enjoyed this problem. Shall we go ahead, students?
Yes.
Yeah, thank you. Now here is another typical situation. Well, I think you can figure it out. I'll give you 2 minutes, just prepare the strategy for this. Well, I think the strategy is quite simple here. The two springs are in series. Hello?
Yes.
So therefore, the equivalent K will be what? K equivalent. Quickly. K equivalent will be this into this. That is 2K into K divided by 3K. Correct? So this becomes 2 by 3K. This is the K equivalent. Quickly. Now you have to also understand that whatever energy is released by each of the springs, that will travel to each of the mass according to the ratio. I mean, supposing this was M1 and M2, it would have transferred accordingly. I suppose you have to appreciate it. Okay? Hello?
Ratios of?
See, supposing this was M1 and this was M1 and M2. Okay? Then you see, when this spring is compressed and it is expanding, so the energy exchange is taking place from this to this. Okay? So if this releases energy, assuming that, then that energy will go from here to this and also to this, proportionate to the mass. Just like how, if you apply force and there are two masses in series, then the force distribution will be such that acceleration will be same. Correct? Isn't it? The force will get distributed according to the masses. I suppose you understood that whatever I meant here. So therefore these two will come, the energies will get transferred. So therefore these two masses will also come in, these two masses will also come in parallel. Okay? These two masses will also come in parallel. Okay? So therefore I will say mass equivalent. So mass equivalent here will also be M into N divided by M plus M. So that gives you what? M divided by, hello? M divided by 2. M by 2. Correct? I have explained this when I taught you spring. I think you have all forgotten. Okay, this is something that I have explained using electrical analogy, etc., etc. Okay, so this is what we have the equation. Now they are asking you time period of oscillation. So the omega here would be what? Omega here would be root of K by M. Okay, then this one. So in this case, you just have to substitute these values. Okay, so what will be the value of K? That is 2 by 3K. And what is the value of M? M by 2. So this should give us what? Root of 4K by 3M. Hello, are you with me?
What time?
They asked time period, so you just have to convert it into time period. So to convert it into time period, then omega is 2 pi by t. So 2 pi by t. So you want this will be equal to so and so. whatever it is. So you have to invert that, push this one there. So E will be equal to 2 pi into root of 3m by 2. Okay, hello? Hello, I'm asking you, is it okay? Huh? So C is the option for this. Got it? This is a simple illustrated problem that we had solved in our regular class. Now this is once again I have resolved, I can say this. Okay, shall I proceed? You have any questions?
Mass equivalent.
See, that's what. Now you see the energy from each of these springs will see. Supposing this relaxes, through this is going to go here also, right? See now here. Here the situation, see, that is energy gets released to both. Therefore, that means now whatever energy is released, that is traveling to this also and to this also in parallel combination. See what happens here. What happens here, right? If you see this situation here, okay, these two springs are in series. This situation is similar to what? The capacitors in series, correct? Do you remember? These two are similar to capacitors in series, and these two masses are something like the inductors are in parallel. Okay, so this gets connected. So this is the logic with which it has been equivalent mass.
Yes.
Got it? I have explained this with this logic. Okay, done. Shall we proceed, students?
Yes.
Okay. Aram se make the strategy for this. If you make the strategy, done. Now look at these. I hope the problem is simple. It's to be understood. It is quite simple. Correct? Hello. Now what I will do is this root 2. Approximately root 2 means what? Approximately 1.5. Correct? 1.4 and 4. I am taking it as 1.5. Hello. Yes, no, the time save 1.4. This 1 by root 2. 1 by root 2 becomes what? So 1.4 is, I write it as 1.5. This 1.5 I can write it as 3 by 2. Okay. This 1 by root 2, this value. So this 1 by root 2 value, you can write it as what? That becomes 2 by 2. Correct? Just to get an idea. So now what you can see is the spring is compressed to 3 by 2. Right? And this wall, the distance from this wall, they have given it as 1 by root 2. Can you see here? That is, from here to here it is 0.6 centimeters. But from here to the mean position, that is relaxed position. If you take this as a relaxed position, right? So this distance would have been how much? This should be 3 by 2. And this distance is 2 by 3. Got it? That means try to understand. Okay. Now presume that this wall was not there. This mass was here. This would have been like this. So now this mass is pressed and brought it to this point. Agreed? Okay.
Yes, sir.
So that means spring is now compressed, and now you assume that you have placed the wall. Now assume that you have placed the wall. Correct?
Yes, sir.
And now if you remove your hand, this is going to go strike this. This is going to strike this wall, and again it is going to come back. So the oscillations will happen between these 2 points. Agreed?
Yes, sir.
So now that means now this is compressed by this value. Correct? Hello. So what I will do now is I would straight away going for our standard technique, right? So I will say that I will take it as what x is equal to a sine omega. I'll take it like this, and therefore in this compressed condition, I will say that the phasor is in this direction. Agree? Under the, see now this is compressed at this position, this phasor is in this condition, correct? And the length of this phasor I will take it as root 2.
3 by 2.
Root 2, that is 3 by 2. Okay. Root 2 I will take. I'll take it as root 2. See, I wrote 3 by 2 because we can get an andas of the wall and other things. That is it. I hope you are following me. This is this.
Yes, sir.
Now the vector is set to, this phasor is set to rotate, and it will stop, it will hit the wall after traveling a distance of 1 by root 2, that is 2 by 3. Correct?
Yes.
So therefore, now I will, that means now this phasor would now come here. This phasor would now come here, and in the what is this one? What is this value? What is this value now here? They have given it. This value is 1 by root 2.
Yes, sir.
Correct?
Root 2 minus 1 by root 2.
Is it root 2 minus 1 by root 2 or 1 by root 2?
Yes, minus 1 by root 2. Minus 1 by root 2.
Correct? Root 2 minus 1 by root 2. Hello, all of you participate, man. Only 1 or 2 students are participating. ಏನಪ್ಪ ಮಾಡಲಿ ನಾವು?
Root 2 minus 1 by root 2.
Root 2 minus 1 by root 2. We'll take it. Okay. Correct. So good. No, Darren, you also participated. Root 2 minus 1 by root 2 will be this time. Right? So this will be root 2 minus 1 by root 2. So what is this going to be? 2 minus 1 is 1. So this becomes pardon, 2 minus 1 is 1 by root 2. Hello?
Yes.
This is also going to become 1 by root 2, no?
Yes.
Right? 1 by root 2. Right. This is also going to become 1 by root 2. So now this vector is having value root 2. Okay? And if you take this as theta, and if you take this as phi, okay, either way. So if you take it as phi, then cos phi, a cos phi, that is root 2 cos phi will be equal to 1 by root 2. Correct? Hello?
Yes, yes.
Therefore, phi will be equal to 60 degrees. And theta will be equal to 30 degrees. Correct?
Yes.
Hello?
Yes, sir.
So that means now, you see, this phasor will start from here, this phasor will start from here, go up to this point, and then once again return from this point to this point. Correct? So this will oscillate only within this range.
Yes.
That's what it is going to do now.
Yes.
See, because that is what it is going to do. It is elastic collision. Correct now?
Yes.
Aram. So now they have, what is the next condition they are given? Now you see, when the block is released, it makes elastic collision with the wall, and its period of motion is 0.2 seconds. That means for it to go from here to here, it will take 1 second, 0.1 second. For it to come back here, it will take another 0.1 second. That is the time period. Correct? Okay. Now, okay. Now, that is what is the situation. Now, with the given things, what are the things now we have got now? That is the phasor is root 2. The phasor is root 2, and they have asked us to find out the value of k. They have asked us to find the value of k. Now, what is the logic? If this wall was not there, then what would have happened? It would have simply oscillated, no? Okay, and then the period of the frequency of oscillation, you would have written it as k by m. Correct?
Yes, sir.
And the period of oscillation, you would have written it as what? 2 pi by t is equal to k by root k by m, or t is equal to, well, you would have written it as 2 pi into root of m by t. Correct? Hello?
Yes.
Right. So they are asking us the value of k. Now we have to get the value of t. If we get the value of t, then we can get the value of this. Correct? So here we see, for this to transit from here to here, that is 60 degrees, it has taken 0.1 degrees. That is, for 60 degrees, it has taken 0.1 seconds. So supposing this would have travelled completely and come back here, it would have travelled 6 steps.
Yes, sir.
Okay, then the period t would be in its natural condition. Natural condition, got it? T in its natural, that is without wall. Without wall. Okay, it would have been how much? 0.1, it would have been 0.6. Clear? Hello?
Yes, sir.
That's what we can conclude? Right. Okay. So, shall we proceed? So, this is going to be 0.6. Okay. And, they have given one more pi square value they have given. So, straight away we will make it t square. And here this becomes 4 pi square. And into m by k. So, we want k. So, 4 pi square value they have told us to take it as 10. And m value they have told it as 0.9. 0.9 what? kg. Okay. And t value we just got it as 0.6, isn't it? Hello? 0.6 into 0.6. Okay? Hello?
Yes, sir.
So here, see, 9 4s are 36, 6 6 are 36. They would get cancelled. Correct? Hello?
Yes, sir.
So I will put a point here and multiply it by 10 to the power of minus 10 to the power of multiplied by 10. So then 0.9 into 0.4 becomes 0.36. 0.6 into 0.6 becomes 0.36. So I can straight away knock off these two. Okay? So I will be left with what? 100.
Yes.
I will be left with 100. So K value will be 100 Newton per meter. Do we have this option? Yes, we have this option. Okay, so now let's see whether that option is right. Which is this problem? 17th problem. A is the option. Correct. You got it right. Okay, you can see here logic, mathematics, everything is in order.
Yes.
Right? Okay, fine. Happy students?
Yes.
One doubt, ask.
Sir, like if that wasn't the wall, like it was some kind of body was there. Sir.
Pardon, I didn't get you. Once again, ask.
Sir, if that thing that they showed in the figure, sir, that was a kind of a card, sir.
Which was this kind of card?
That thing U-shaped.
U shape.
Uh,
What U shape?
walls they have showed no sir.
Wall they have shown.
The walls were like movable.
What walls are movable?
Sir, after that collision, sir, won't that body stay there or what will happen?
They have told elastic collision, no man. They have told elastic collision, it has return.
So, but that wall also can move.
Wall, they have made it sturdy, it is non-viable.
No, sir, I am asking you.
Hey, see, then the problem is going to be different, gentlemen. Let's not complicate it. We'll take up. See, what I have decided, no, this phase 2, I am taking up some numericals like this and going ahead with this. Okay. So, anyways, your examination is in March. So, we will have phase 3. In phase 3, I will take the numericals which are higher than this. Okay, which are higher than this. So, definitely we will encounter some numericals of that level. Got it? We'll go in stages. This itself is a complicated problem, but I have chosen such problems because, there is, from the basics we can build the problem and we can solve. That is the intention of me taking some numericals like this. Because I would like to connect this directly with your NCERT textbook. No high-tech thing. Okay, this you can solve if you have understood NCERT well, with a bit of logic, you should be able to do that. Shall I proceed?
Yes.
See, your time is more precious than. Solve this problem. So write the equations correctly, then it is done. Length of the spring, you understand that, length of the spring we have told. So you take the initial length of the spring to be L naught. Okay, relax that. Then you have to write the equation, simple equations. 4 will be equal to 4 Newton they are told will be equal to what? Alpha minus L naught. First equation. Then they are told 5 newtons. So 5 newtons will be K into beta minus L. Okay. Then they are asking here 9. They are told 9 newtons is equal to K into, you take it as gamma minus L. Okay. So they want to find out gamma now. If you see this one, gamma as a function of alpha and beta. That's what we have to do. And K should get eliminated. I think you cannot do this, a bit of manipulation. So we want to retain this, you have to knock off this L naught. So I want to retain this. So my logic would be K into gamma minus L naught minus K into alpha minus L naught. Okay, so the L naughts will get removed. At the same time, I have to knock off this K's also because the equation should stand with this. So best thing is, if I do this manipulation, L naught will be knocked off, but K will be retained. I have to knock off this K also. So I will use the second equation. So I will once again write this minus K into beta minus L. Understood the logic, students? Hello?
Yes, yes.
So here automatically you see in the numerator this KL naught KL naught, in the denominator also KL naught KL naught will get will be knocked off, and all the K's are common here, so all the K's will also get knocked off, and all the L naughts will also get knocked off. Clear? Hello? So this one. So K into L naught is 4. This is 4, and K into, sorry, this is 9. So 9 minus 4, and this is 9 minus 5. Okay, and this will be equal to what? 5 by 4. Okay, so I will straight away write here 5 by 4. I will just be left with gamma minus alpha, and in the denominator gamma minus beta. I will write it. I think we have to solve for only gamma. So just cross multiply this. You get here 5 gamma minus 5 beta is equal to 4 gamma minus 4 alpha. So I shift the gamma here. So I get gamma here, and I will get here 5 beta minus 4 alpha. So this is the answer. So do you have this option? 5 beta minus 4 alpha? Yes, it is. I hope you understood this logic, students.
Okay.
See, this is how, see, if you look at it, you should get the feel, because we have to retain this. Okay, at the same time we have to knock off two of the variables here, and this is the way to handle this. So fundamental logic, because we are going to encounter such issues. So this is how we have to do this. Okay, shall we proceed?
Yes.
Yeah. A horizontal string is connected to mass M. The ratio of the frequencies. Well, quite simple. G. The ratio of the frequencies. So, omega 1 will be root of K by M, and omega 2, yes, so that is quite simple, M plus beta. So they are asking you the ratio of the frequencies before and after. So omega 1 upon omega 2. So if you take these frequencies, omega 1 upon omega 2, so we will be left with M plus M divided by small, no, it's capital, sorry. So that should be an option. Right? So this is omega 1 plus whatever the root of this. M plus, they are asking you the frequencies. Right. Okay, which one?
Okay.
Option. No doubt. Okay, I think we shall proceed. Quite a simple problem. A pendulum is suspended from the lift, and the pendulum at T naught. What must be the acceleration of the lift? Come on, all of you solve this quickly. Now your speed should pick up, because you have solved similar situations before. Therefore, it should become T naught by 2, obviously. So lift is going, it has to go, because G has to increase. So we have to take the lift accelerating upwards. So this will be G plus A. Lift is accelerating with A, that's it. Okay, so you get here calculation, 2 will be equal to root of G plus A divided by G. Right? So here 4 will be equal to 1 plus A by G, or 3 will be equal to A by G, or A will be equal to 3G. This is the option, and this is going upwards. Okay. Simple. I think, the situations we would have solved similarly, you should be able to analyze. Yeah. Shall I proceed?
Yes.
New clearance quarter fatapat mundu hogodu. Two simple pendulums having periods 2 and 3 seconds respectively after the mean position simultaneously at a particular position. They may be in phase after an interval of. So I will get a mental picture of this. So this is A and B. A means 2 seconds and B means 3 seconds. So both are at this position to begin with. Okay, and it takes 2 seconds and it takes 3 seconds. So when A has completed one revolution, that means it has gone to 2 seconds. So this takes 3 seconds. That means this one will travel 120 degrees, 120 degrees. Correct? 120, that is 240, and this. So after this has completed one revolution, this should be here. The second one would be here. Got it? Hello? Because this should have taken 2 seconds. At 2 seconds, this position of B will be here. Position of A will be here. After the first revolution. That is, got it? See, this should have traveled by 2 seconds. In 2 seconds, this is here. So this is lagging this by 120 degrees. Got it?
Yes.
Lagging this by 120 degrees. Okay. Now let's see, because now when it completes the second revolution, that is, it has gone 4 seconds. Okay, this has traveled 4 seconds. Then the lag here will increase to 240. That means this B will now come to this position. Correct? 240. B will now come to this position while A has come to 4 seconds. Hello? Understood the logic?
Yes, sir.
And then that is lag was before 120 degrees. Now the lag is 240. Correct? Because this has completed 2 revolutions. Now it completes 6 revolutions, and the lag would now be 360 degrees. Okay? So after 6 seconds, both of them will be in phase.
Yes.
So they will be in phase after an interval of
1 hour.
Then we are somewhere wrong. Where did we go wrong? Correct now what we have done?
Yes, right.
But they have given option. This is 21st problem. They have given option B. I don't see there is any possibility of that. It should be 6 seconds. It's simple math. I think it should be 6 seconds. They are not given the options. They are wrong. We are right. I think we are right. I don't think there is any hassle in this. Okay? We'll go with this. But anyway, keep it open. You can discuss tomorrow in the college if you want. Okay. Fine. Let me proceed. So the option is not given. The answer is actually 6 seconds. So it is like this. The pendulum is like this. It is doing like this, perpendicular to the pole, right? Normal to pole. It should not be difficult for all of you. By inspection, you should tell this. See the basic definition. When a pendulum is oscillating, then the length of the pendulum will be from the point of suspension to the center of gravity. Correct? Center of mass. Hello. Correct? Hello.
Yes.
So here the center of mass is this only, right? And it is as if it is suspended from this point. And this length will be L by root. So this option should be the right option. No doubt.
Yes.
So 22nd is B, correct. No doubt about it. There is no other go. Correct, no? Effective length.
Yes, yes.
No, don't now start taking any tension and all here. Right? Okay. Fine. Solve this. Okay. Very simple. They are told n oscillations per minute to confuse us, so don't get confused. In the ratios, everything gets this one. So this will be
Option C.
Option C. That's it. So n
Yes.
1 n plus 1. Okay, should be equal to everything else will cancel. The ratio of the lengths. It's only the lengths that matter. So this length should be L1 and this length should be L2. The ratio of the length of the first pendulum to the length of the second. Correct now? So L1 upon
Frequencies.
this is frequencies. So therefore it should be ulta. It should be ulta. That is the catch. Okay. So this should be equal to so n plus 1 square upon n square, whatever it is. So right. Okay, C is the option. Okay, done.
Yes.
Right. Ha. See, I was waiting for this problem today. Now handle this problem. Now we have entered, see, so far we were handling only simple pendulum, right? Now we have to handle compound pendulum. Simple pendulum means, a string with a bob, right? Okay, or a spring mass system. That is another system that we have seen. Now here, it's a rod. The rod itself oscillates. So if you recollect the theory for this with one single rod, then you can solve this. So for that theory, do you recollect the theory for a rod? That is, I have a rod. Now a rod, this rod is suspended. This rod is suspended. Okay, hello? This rod is hinged. So if you remember this is the rod of mass m, length L, and it has to do. So if you quickly can know how to do this, we can do this. Do you know how to handle this? Hello? Can you handle this? So you find out the frequency of this, omega of this. Then we can do this properly. Then we can solve this problem. Can I handle this, students? If you say yes or no, shall I do it? So this is mg, this is theta, so this becomes mg, this becomes sin theta. Theta is very small, so approximately 20. Okay. So then this length is L. Okay. So therefore, the torque it develops will be L into mg sin theta. So L mg theta. Got it? Okay, and this should be equal to the I into alpha. And I is for this what? M L square by what? 3 into alpha. Okay, so the m's will go and one of the L will get knocked off. So we get here 3G by L into theta is equal to alpha. So as you know, alpha is proportional to minus omega square. So we get here omega square will be equal to 3G by L, or omega is equal to root of 3G by L. I think we have done this derivation. Hello? Hello?
Yes.
And I gave you this as a small question here. If you have also got this answer, I will be happy. Did you also get the same answer? No. Okay. Forget it. So this is the logic used here. This is the logic used here. Only thing is I have shown this vector mg sin theta here, but is it correct to show it here? Mg sin theta. Hello? It is wrong. So it should be shown here. Mg sin theta should be shown here. Okay, at the center of this. Okay, and this should be L by 2, not L. Got it? Nana matadakatini, Nana question karagade, Nana answer avagade. So these two should keep coming down. Okay, so that's it. Do you remember having done this?
Yes, sir.
You got the same answer?
Yes, I got it.
You got this one below? 3G by 2L? Adil?
Yes.
Okay. No, I just want to confirm, man, because I have also done, if you do and both of us get same answers, then the probability that what we have done here is right. That's the whole idea. That's the whole thing. And we are learning. Okay. Now extend this to this. So in this case, where will be the center? See now the center of mass of this. The center of mass of this will be here, and the center of mass of this side will be here. Therefore, the combined center of mass is here. Got it? Hello. The combined center of mass is here. That means this side is m, this side is m. This will be what? 2m. That is, if you assume that you know the concept of center of mass, assuming that the entire mass is concentrated at the center. So that is precisely what you have got to take. Okay, and they have got it is L shaped, so this should be 45 degrees. Therefore, this length should be what? This length. Length should be L by 2 cos 45. That is, this length should be what? L by 2 root 2. See, L into cos theta. Cos 45 is L by root 2. But from here to here the distance is L by 2. So this becomes L by 2 root 2. Clear?
Yes.
So that is the thing. So extend the same logic to this. Whatever you have done here, the same thing you have got to do it there. So you have to write the equations for this. Similar equations for this. If not same. Right. So start writing the equations for this also. So you get here tau is equal to, for this case, it is going to be again this will be no 2m. So it will be 2mg sin theta, and this is located at what? This is located at what? At this point. And what is that point? That point is L by 2 root. Correct? And this should be equal to the moment of inertia. So the moment of inertia of each rod will be m L square. Should we take L square there? Yes, we should take L square. When we are taking the momentum, we should take it L square. M L square by c, but there are two momentas. So that is m L square by 3. I am taking. I into alpha. Correct? What I have written is correct? Hello, quickly tell me, have I written it correctly? Ye maatadi. Okay, fine. So as usual, this will become only theta. So 1L and this will get knocked off. M's will get knocked off. 2's will get knocked off. Okay, and therefore I will get here alpha will be equal to G 3G. Okay, 3G by 2 or root 2L into theta. Because theta is very, very small, that is the consideration we have to take. Right? And therefore, the omega square is going to be 3G by 2 root 2L. What have they asked here? They have asked period of oscillation. Correct? Hello? So period of oscillation they have asked. Okay. So that means now this will be 2 pi by t. So t will be equal to 2 pi into root of 2 root 2 L by 3G. Do you have this option? 2 root 2 L by 3G. There is an option. Hello? So which is this problem? 24th problem. P is the option. Wow, fantastic. P is the option. We got it. Clear?
Yes, sir.
Okay.
Yes.
Now thank you very much.